Super. We need to take the questions, I guess. So we're just going to get started, but before we get going, there's a couple of administration kind of things I need to do. So because we're outside of university hours, I need to tell you about fire. So there's no fire drill scheduled for this evening, so if we do hear the fire alarm sound, we have to make our way to the nearest exit. So if you follow myself, I will take you out to the muster point, and Callum will lead up the rear. That's that.
Yeah. So please take a seat. Yeah, we're just going to do a really quick 5-minute whirlwind introduction to the topic of de-extinction and try and make sure everyone knows what we're talking about before the debate teams get started and really get stuck into it. And we've ended up calling ours Pigeons Rule, Dinosaurs Rule, and that's because we sat and picked apart Jurassic Park and the reasons why Jurassic Park is scientifically the worst movie ever.
So there's several reasons why Jurassic Park is not very scientifically accurate. Mostly because most of the dinosaurs are way too big.
Yeah, Jurassic Park was bad for this, but it got worse and worse as the series went on, with Jurassic World really taking the biscuit, with dinosaurs bigger than any animal that's ever existed.
Also in the movies, the time frame is completely wrong, because it's estimated that it would take about 15 to 20 years for dinosaurs to reach full size, and in the movie it's shown over a very short period.
Even the amount of blood that they use in terms of it, they use a mosquito full of blood. We've looked at it, it's more like you need hundreds of mosquitoes across hundreds of different dig sites to even begin to build yourself a small dinosaur.
Yep. Also, in the movies it's shown that amphibian DNA is used to fill in the blanks of the genome, but in reality we now know that birds are more closely related to dinosaurs, so it would actually be a bird genome that would be used as opposed to a frog.
And because of that, there is essentially no animal alive today that would be able to carry a dinosaur egg to term without killing the animal and without the egg being unusable. So essentially, dinosaurs were the wrong way to go for Jurassic Park.
What they really should have been talking about is one of the following species. So these are species that are actually under consideration for de-extinction at the moment. So we have the giant sloth.
We've got the Cuban red macaw.
The New Zealand giant moa.
Tasmanian tiger up there in the top right.
There's also the American carrier pigeon.
Saber-toothed cats.
The dodo.
And of course the mammoth, the namesake of this debate. So in a bit of research into it, we decided to look into a recipe to make a mammoth. What you need to get together and the process you need to go through in order to build one.
So in order to make 1 to 2 woolly mammoths, you first need to get yourself a female elephant and leave it till it's approximately 12 years old.
And then on top of that, you need to have got your gathered DNA. We'll just assume that we've got a whole mammoth genome that's been isolated from all sorts of geological samples. On top of that, you need to then take the DNA and put it into the ovum without causing too much disruption to the cell.
The gestation period of elephants is around 21 months. So you would have to first allow the mammoth to cook for 21 months before getting a mammoth calf. But even here, the genome would not be complete, so this would have to be repeated a couple of times before you're able to have one that's DNA was close enough to an actual mammoth.
To be able to call it a mammoth. So, with that in mind, we were going to ask if anyone was going to hazard a rough guess that if we were to start right here today, if we were all to head away and start working on this project, how long it would take us to get into the first mammoth birth. Anyone's got a guess? Kevin, I know you've got a guess.
I'm going to be conservative and say 15 years.
Yep, it would probably be around about there.
So we've got the 12 years, we've got the 21 months per gestation cycle, but on top of that, the real problem is we don't actually have the knowledge to put this into practice. We've got the theory down, but we've not got the practice down. We've even got the DNA. We found a really well-preserved, scientists in Russia found a really well-preserved 30,000-year-old woolly mammoth calf, and it has almost a full genome, so they would be able to do that.
Ethically, the production of a mammoth is also completely unfeasible as well, because elephants are endangered and there's no way that you would secure a home license for animal experimentation using elephants.
So that's why, out of all of the things that were looked at, out of marketing from dinosaurs, out of looking at mammoths, we came to the unlikely hero, American carrier pigeon.
So this is Buttons, and she is the last known specimen of the American carrier pigeon, and she was named as such because when she was taxidermied, they put buttons in her eyes.
Yeah, she was shot in 1920 in Idaho, but the taxidermists were foresighted enough to be able to preserve some of the tissue, so we do have Button's complete genome frozen away for potential future use.
And obviously with the American carrier pigeon being quite similar to species that are still alive today, it is feasible and we do have a live animal model that could host.
So, on top of that, we've got all this lovely genetics. This is the technology that has really made it worthwhile and potentially useful within the next coming years. It's called CRISPR, which stands for clustered regularly interspaced short palindromic repeats. I'm not going to go too much into it because it's not a genetics lecture. Sorry everyone who came expecting that. But this is essentially the technology. It's a pair of molecular scissors which would allow us to go in and edit the genome to the way we want it to be able to produce the new species.
But we've been talking for long enough, so we're going to get on with the debate now. And we're going to hand over to Rosie, who is president of the Debating Society and our MC for this evening.
Alright. I just want to start by thanking you all for coming. It's really great to have a good turnout, and thank you very much to Callum and Steph for that introduction into the topic. General structure for the night is that we have a for side over here. We're going to let them talk for 10 minutes from an argument they've prepared, and then we will allow 10 minutes for the against side. There is also other members on down here in the front row, as we have a rebuttal, which will be 5 minutes for each team. And then after those, we will open up to audience questions, and you guys can tear into them. So just before we start as well, the motion is this House believes that de-extinction is ethical and beneficial. So I wondered if I could take a quick poll, and PowerPoint's failing me. Okay, yeah, so can I just ask who believes that de-extinction is both ethical and beneficial? Could you put your hand up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's great. And who is against this motion? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And who is abstained? So they're not really sure. 1, 2, 3, 4. Great, thank you very much. So after that, can we just 10 minutes for the foresight? Here we go.
Okay, we're here today to argue that de-extinction of extinct species is both ethically and practically the correct thing to do and a good thing to do. We believe this for a number of reasons. The first one concerning biodiversity and how de-extinction might improve biodiversity all over the world. Biodiversity, the number of different species available in one location, is something you want broadly. It's a large amount of biodiversity boosts ecosystem productivity, and a larger biodiversity means a larger range of plants and animals for humans to use, for humans to exploit. For example, in medicine, in commerce and agriculture, business, all of these things. There also could be social benefit of biodiversity. More animals to see, and more plants to see, and more different areas to visit could increase tourism. It could also be a benefit to education. If there's more there's more to teach about. And healthy ecosystems can also better withstand and recover from natural disasters, because if there are more different types of species there, it's more likely that some of them have the capacity to survive a disaster. De-extinction will increase biodiversity, not just because we are adding one more species to the range of species we have available, but because some of the species that we would add would increased biodiversity as a side effect of them being added, because they are species that are key to the natural order of that particular place. An example of this would be the reintroduction of wolves in Yellowstone, which Ailey is about to talk about.
The Yellowstone wolves were added in 1995, and they've increased the beaver population, which before they were reintroduced was just 1 colony of beavers to 9 colonies of beavers. So, and they've also changed the eating habits of the elk that lived there. The elk population was huge before the wolves were introduced, to the point where they were foraging plants way too much, not giving the plants enough time to recover. So with the wolf reintroduction, elk have become much more vigilant in terms of keeping an eye on the fact whether or not there are wolves about to hunt them, which means that plants such as willow have had more time to recover. The elk forage less for it, and willow is one of the key things that beavers need to survive. Another example of reintroduction that has helped the ecosystem is the reintroduction of the European beaver in Scotland. The beaver, in making its dams, has helped flood control, erosion control on the rivers, and it's increased the ecosystem resistance to potential disturbances. And it's also helped increase in pond and deadwood species. And it's also helped provide food and cover for adult and juvenile fish, and promoted regeneration of target species such as willow.
So yeah, as we can see, the reintroduction of wolves in Yellowstone, who were eliminated 70 years prior, increased biodiversity. A similar result could be attained from the reintroduction of extinct species to other areas. For example, the passenger pigeon, for example, lived in deciduous forests in North America. The reintroduction of the passenger pigeon could support more forests support more pigeons, and increase biodiversity. And while it was said that the mammoth would probably be impractical to bring back, if it were brought back, it might turn a lot of the northern Siberia tundra and forests, which have a relatively low level of biodiversity, back into the grassland that was previously sustained by the mega herbivores, foraging and knocking over trees and fertilizing the ground.
So as well as the whole species de-extinction, one of the things we think needs to be considered when talking about de-extinction is the fact that with reintroduced species, as an analogy, de-extinction can also be used for individual genes. So when you have a reintroduced species, a lot of the times over courses of generations, you lose biodiversity. Deleterious genes build up in the population because you have a small breeding population. So for example, with the Mauritius kestrel, which was reintroduced after in the 70s, fall into a population of only 4 birds globally. About 25% of those birds, after a couple of generations, all the breeding pairs were very closely related, and you were losing about 1.6% of their genome every generation. And at that point you get to a stage where you end up with only the deleterious copies of genes. And that's one of the big problems with reintroduction. You can use de-extinction of individual genes by taking healthy copies from banks of genetic material that we have in what are called frozen zoos, where we keep the genetic samples of endangered species. And you can actually reintroduce the healthy extinct gene into the animals, and you can drastically improve the diversity within the population, which again helps the reintroduction of an endangered, dying species back into the wild, and you can really help that species begin to flourish. Now I'm going to tap out for Dustin because I'm not well, so he's going to take over from here.
Yeah, I apologize for this little commotion, but as Sam explained, he isn't feeling too well. So as Mike, and he has more actual factual knowledge about the sciences of genes than I do, but as my colleagues have explained, we have not we have the issue of biodiversity, which de-extinction would help improve, but also we would like to raise the point that it's also that we also have a moral obligation to try to further the sciences of de-extinctions, because a lot of the animals or a lot of the fauna that has been extinct is because humanity has caused this extinction either by hunting those animals until there were no more of them, or by destroying their natural habitat and therefore reducing their living space and causing them to reduce their population to a point where they could no longer sustain themselves. So, and since we caused this by spreading out and destroying those environments, we have now in the past made an effort to stop these processes, so it's only a logical conclusion that we also should try basically fix what we broke by trying to repopulate the nature with the animals that we took out from it or that we drove out of nature.
Yeah, so in conclusion, we believe that there is a strong practical and ethical argument to the de-extinction of species that other extinctions caused by humanity, and we think it is something that should be pursued.
That's great. That was pretty much 10 minutes on the dot, so perfect.
Excellent.
And I will just have 10 minutes from the against side.
Good evening. Well, it's never easy to be the doomsayer, but unfortunately, we hold that de-extinction is essentially just not a very good solution to a problem that is more or less a very small part of what we ought to be doing in terms of conservation efforts. Even in the most optimistic projections, it could only be an infinitesimally small part of any real conservation efforts, insofar as you're creating so few individual animals that it would take so long to come up with any kind of viable population. You talked about small breeding populations. Well, that's what you get with the extinction efforts. You can only create small numbers of individuals at any given time, and so getting to a point where there would be enough biodiversity for these things to survive, it may well not be within the lifespan of these animals, never mind the capability of us to, in fact, reintroduce these creatures. The argument from biodiversity is essentially that a greater biodiversity is always a boon. This is not necessarily the case. Simply increasing the number of species in an ecosystem is not a magical cure-all to necessarily improve the environment. It also matters what kinds of species are being reintroduced and where, and whether the existing biodiversity is functioning well or is functioning poorly. The reintroduction of certain species might cause catastrophic effects. It could be the case that a de-extinct mammoth or thylacine would outcompete, or in fact be outcompeted by existing elements within the ecosystem, thereby either supplanting an extant species, thereby making that extinct instead and merely replacing one extinct creature with another. Or essentially your de-extinction efforts fail, and the reason that this creature went extinct in the first place hasn't gone away.
If I may interject, briefly, I would like to address Dustin's point about moral obligation towards de-extinction. I feel this perceiving the extinction as a moral obligation of humanity is a bit of a double-edged sword. You will see that particularly in the US, I think it was the case of the spotted owl that was being severely endangered by by rapid deforestation. Scientists providing testimonies before the Congress were asked questions that essentially boil down to, in the event of the owl going extinct, can we, for example, secure enough specimens in captivity to then reintroduce it? Or something along those general lines. The point is that what this question actually means is, can we continue with the deforestation effort, if you will, because our excellent scientists can bring the owl back, which essentially defeats the purpose of a conservation effort in the first place. The extinction in this case appears to be more of a little bit naive way of telling things like, don't worry, we'll handle this, you can continue as you were, where it's actually counterproductive to the conservation effort in the first place.
And you also talked about the passenger pigeon as a species that's going to possibly come back. With the passenger pigeon, it nests in thousands. So in order for that to actually survive as a species once again, you would have to bring back thousands of them. Now, we only have the genome for, what is it, one? How on earth are you going to bring back that many passenger pigeons with that same genome? You're not. It's not feasible to do. And if you do have more genomes for it, with the interbreeding, and to get that number of pigeons you need for it to survive, you're going to have interbreeding, and that's going to cause mutations in the genome, and it's just going to rapidly decline. So your conservation efforts and your de-extinction efforts there is not going to be worthwhile.
There's also the issue that it's just we feel it's a massive oversimplification to bring back, say, the mammoth or the passenger pigeon. None of these species exist in a vacuum. And so you're talking about potentially thousands of different organisms that are necessary to the survival of these creatures. You're talking about parasites who may feed on them. You're talking about predator and prey species. You're talking about their own gut flora. You're talking about the creatures that depend on these animals for survival that may also be extinct, or vice versa. You're talking about animals on which these de-extinct species are reliant on for their survival. So the reintroduction of any animal in a vacuum is, we feel, it's a naive view. It's not taking into account the complexity of the interrelation between the species living in an ecosystem. So in conclusion, we would like to put a couple of hypotheticals. Essentially, what is the end game of de-extinction? It seems that there are two options. We keep these animals in perpetual captivity, so that they don't suffer. We don't suffer these negative effects on the natural ecosystems that currently exist, and we can supply them with the kind of care that they may need if certain things are lacking in the natural environments. We would have to supply it. They would be essentially domesticated creatures. You then get into the ethical problems of keeping an animal in captivity for its entire lifespan, and not only that, but bringing an animal back, creating an animal specifically for the purposes of keeping it in captivity for its entire lifespan. The other outcome, the other potential end game is reintroduction. But again, we've touched on some of the issues that these reintroductions can cause, particularly with species that are not extant. The reintroduction of wolves is, I would say, less problematic because we still have plenty of wolves, or at least a considerable number. We don't have any mammoths, and we're 10,000 years removed from any mammoth interaction with any ecosystem on Earth. And so it would necessitate all kinds of things, the creation of enough individuals to have the genetic diversity to survive as a wild species without our constant interaction. We would need to find somewhere to reintroduce these creatures that wouldn't throw the present ecosystem into complete disarray. And you're now talking about an incredibly rare species that only exists in a very small part of the world. And what already happens with species like that is massive poaching. And so if you think that elephant ivory is valuable, mammoth ivory, mammoth meats, mammoth pelts would be even more valuable to these unscrupulous individuals who would kill them. And so essentially we would have to look after them even after reintroduction into the wild. And this is just, I think, another form of domestication. It's domestication masquerading as reintroduction. So what is the end game?
Great, that's your time. Thank you very much for the against argument. We're going to allow 5 minutes of rebuttals for each side. So the fourth side, you have 5 minutes if you want to make any comments before we go to audience questions.
Can I start something? Okay. What I would like to start with is, one point you've constantly been working on in the last couple of minutes of the argument was the whole mammoth thing. I think you or the whole process of de-extinction is not only focused or not so much concerned with actually bringing back the mammoth. As we have heard in the beginning presentation, it's actually not a very feasible thing to do. But what the mammoth does, as an example for de-extinction or the possibilities of de-extinction, is bring attention of the public to the process. And with public attention comes funding. And the research into de-extinction is not necessarily its purpose to bring back this one special species, but it has multiple applications and also helps conserve actual animals that are already in ecosystems, but their population is dwindling. Another example we have for the kind of inbreeding problem we have is the Tasmanian devil. The small population that still is there suffers from a form of cancer that is caused by their dwindling diversity. With another close species that is close to the Tasmanian devil, like one of its ancestors, these could basically strengthen the diversity and the gene pool of this endangered species, and therefore not necessarily swap it out with its ancestor, but strengthen the existing population and make it increase again.
To add to that, we're not arguing that de-extinction is a cure-all for conservation. We are arguing that it is an extra tool in the box for conservation. It is something that can be used in certain circumstances, not all circumstances. Obviously, you'd have to be careful as to where you did it. But there are circumstances where it can be used and where it would be helpful to reintroduce extinct species. And as Dustin said, we also believe that it could be something that drives publicity and public attention for conservation, and additionally drives the sort of genetic research that can help merely endangered species or very endangered species. And while you did say that it was an oversimplification, that we would have to bring back other things, that is again something we'd have to be careful about, and we'd have to, you would just have to be careful about it. You would have to use examples where you thought it was practical, as opposed to just using it as a sort of a blanket case. And additionally, as was said, it might be something, a double-edged sword that causes politicians to say that, well, why bother conserving if we can just bring back? I think that is on a level fear-mongering. I think it wouldn't necessarily happen that way. I think it would drive.
Something that has actually happened.
I say it could happen. But I think it's something that could drive attention towards conservation as opposed to being a hindrance towards it.
Any final points from the core side? No? Great.
Just by all means, Michael, what you're saying about, there's two things that sort of go together here in what you said, Michael. There's the fact that the de-extinction process would draw attention to conservation efforts, and then it's another tool in the box for conservation purposes. With regards to the tool, I feel that cost and in both in resources and time of the tool isn't viable for the results that it brings, given how long you need to wait for the results, given how much effort you need to put in for the results to actually do anything good, particularly in regards to the numbers that the extinction could bring at any given time. Essentially, you don't have to use a jackhammer to break a table. The other thing about drawing attention, I would still maintain my point and say that focus on the extinction would possibly draw attention away from conservations from conservation efforts that are viable, that are practical, and that give you a substantial result given the amount of effort, both in terms of resources and time, they actually take.
There is also a potential, I mean, we may have been falling into this very trap in referencing the mammoth so many times, but it's these charismatic species that tend to be focused on. And this is a problem with conservation, even if you don't talk about de-extinction at all. The symbol of the World Wildlife Fund is a panda, so that is indeed used for publicity. It's, you know, it's a charismatic animal, people think that it's cute, and so it gets people's attention. But in terms of practical and effective conservation efforts, the panda ought not to be our first priority, ought not to be the emblem. It should probably be something like the honeybee, or some kind of frog, or even something further down that is at a more foundational level for the survival of an ecosystem. But again, the reintroduction of these species tends to be focusing on the less essential, larger, aesthetically pleasing animals.
And you talked about bringing back genomes from ancestors. That genome that ancestor has is completely different to the current one. Animals do evolve, and organisms that are on Earth have changed from when that animal was there. Unless it was, say, 10 years ago, maybe not much has changed then, but that genome might not be able to cope with what is currently on Earth. The organisms, the bacteria, the warmer climate, it might not be able to survive, so strengthening that genome might not happen.
And if the genome hasn't changed, the environment can change a hell of a lot quicker than a genome. That's what causes these extinctions in the first place in some species. So, and yes, and again, mostly our fault. I mean, again, I hate to go back to mammoths, but bringing mammoths back into a currently warming planet seems like a recipe for disaster. I mean, that's potentially what killed them the first. I mean, between us and climate change, that's what killed them the first time. I feel bringing them back in any substantial numbers may wipe them out for the same reasons yet again.
Great, well thank you very much then to the panels then, and we'll just open up to audience questions then. So feel free to address either the for or against side if any points you might like to make or questions you'd like to ask.
Can I start off? Excellent points for everyone. I felt like I was changing my mind back and forth the whole time. One question that I'd quite like to bring quite a lot of attention to is all of the arguments thus far have been focused on the animal kingdom and specifically de-extincting animals. How would either panels feel about de-extinction of plants, particularly for things like medical research? You know, we're discovering new plants in the Amazon all the time, and those are going quite some way towards new drugs, etc. So how would the against team, for instance, argue against bringing back plants?
I think with bringing back plants, they would have to be kept in a lab. To introduce them into an environment, they're obviously going to outcompete other plants, and that's just going to lose those plants. So you're just going to have to bring back those. So you're just going to be in a circle, and it's going to keep going.
There's also the question of how would you determine which plants you could bring back for medical benefit. If it's certain plants that were once used for some sort of medical benefit, then conceivably yes, but it seems that you would have to know rather a lot about the plant before attempting a de-extinction, and if you knew that much about it, then wouldn't you be able to apply any potential research? It's almost an observer effect problem that you have to know enough about the plant to de-extinct it. Wouldn't you already know what its medical applications and how to utilize those were before you got to the point of actually having to resurrect the plant itself?
Yeah, over here.
A question to the proposition.
would you not agree that, for example, at the moment, we should focus more on problems such as reducing carbon output or just lowering the levels of deforestation rather than trying to bring animals back to life?
Well, we're not saying that we shouldn't do those things. We're saying that those things are important and we should absolutely do them. But what we're saying is that this is something that can be done as well, additionally, and that will generate enough public interest and enough funding that it sort of adds to conservation as a whole instead of taking away from the pot that could be used on other important causes.
For the proposition side, besides genetics, there are other things that species, when they lived possibly thousands or millions of years ago, had that would be very hard to replicate today. And a single animal on its own in an empty room doesn't know much, but a single animal in a room with a previous group of other animals might learn something. How, if you were to bring back a species that lived in herds, how would you be able to teach it migration paths that no longer exist because it has no ancestors to learn from, and whose areas we might know some things about them and what they looked at, or might not?
Well, I think what you have to do in that case, first of all, you have to be very careful about what animals you bring back. If you think it is practical and possible to bring back an animal, then you should, but in some cases it just might not be possible. Although what you could have is you could have it learning from its descendants and its sort of closely related ancestors in that case.
Everyone for the against side. You mentioned potentially not bringing back animals that could be harmed to the biodiversity of existing ecosystems, animals there, perhaps even humans themselves. However, dancing about bees and the sudden increase in the disappearance of bee colonies of various types, there was a different strain of bees, I'm not sure what the exact word is, that was crossbred in a lab in, I believe, Brazil, a species of African bees, which escaped the lab. And they migrated north, all the way to North America. And all the way through, they gained a reputation as killer bees, because they were extremely aggressive, and they actually managed to kill people, and still do. However, they were found to produce a lot of honey and be very resilient, both to bacteria, and generally didn't seem to be affected by bee colony collapse, at least not nearly as much as more domesticated types of bees. So how can you exclude beforehand, before bringing a species back from extinction, we should consider this species to be brought back, when you don't know what kind of benefits it could have for later on? Because now that African species is looked at, so we can maybe domesticate it and create an entirely new species, less aggressive and potentially more resilient.
I feel that that's an argument from ignorance. Yes, in this particular case, there was a benefit to these highly aggressive bees escaping a lab in Brazil, but that sounds that could be a horror movie script. I mean, and potentially it could have been a terrible thing. It's going to kill thousands. So again, you need to be very careful. I mean, there's no harm in a cost-benefit analysis, but a considerable part of our argument is not that necessarily all of these things will have terrible results and we shouldn't do them. It's that the results are impossible to predict. And so, or at least very difficult to predict accurately at this point because you're talking about such a complex system. And so, the hopes and potential benefits, I think, ought to be outweighed by the caution of a potential catastrophe.
I also think you answered your own question a little there. That's an example whereby, by accident, these bees that have been bred escaped the lab. That's something where we're not even talking about de-extinction. That's like,
that's a happy accident.
That's showing the irresponsibility of scientists when they're not dealing with this subject. Can you say for certain that, I mean, the point of de-extinction is to restore some kind of balance due to the damage humans have done, or even just in the case of maybe just active extinction. But is it fair to take that gamble of damaging what little environment we do have left to try and replicate something from 20,000 years ago?
Can I respond to that?
On you go.
As, I'm sorry, what's your name? Cal. As Cal touched upon earlier with the very good example of plants, it's not necessarily only about increasing biodiversity or completing incomplete ecosystems that go towards collapse, such as the Yellowstone example in the Wolf's Earth. It could also simply have benefits for us humans in some way, perhaps from some venom that the predator has that could allow us to develop entirely new medicine. Not necessarily for the ecosystem alone or conservation efforts.
I agree, but the response would be the same. Potential benefits versus potential risks. You would have to do a cost-benefit analysis, and you can talk about potential benefits all day, but unfortunately you need to have concrete benefits before the pendulum swings, I suppose.
Dustin?
First, one thing I would like to add before I make the actual point I had is that multiple times now, David brought it up again, that it seemed to be focused that de-extinction would try to reinstate animals that have been dead thousands of years ago. Some of the, or most of the animals that are actually in effort to de-extinct have only been dead for maybe 200, 100 years. Now, yeah, around 200 to 300 years. So it's actually not that long ago. And another thing I was actually going to say was that it has been made clear, or some arguments have been made that de-extinction would take so long to actually do anything or bring any results. But I think that's a little bit short-sighted, because when it comes to nature and our planet, I would like to think that we're playing the long game and not just try to fix a leakage with a band-aid, but actually try to do something about the pipes itself and reconstruct them.
Alright, well, to take that last point, the problem is, in the past 40 years alone, 52% of the wildlife on Earth is gone. That's over half in 40 years. De-extinction is an infinitesimally small part of any plan to deal with this sort of thing. And the thing about, yeah, it's not just animals from, say, 10,000 years ago. I brought that up to say that I don't think they have a place in our ecosystem anymore. But even the more recent ones, like the passenger pigeon, because of things like carbon in the atmosphere, even just over the past 100 years, they're not likely going to be viable in another 40 years or so. These are problems that are happening to us now, and we're not dealing with them. This seems like messing around with something that, in certain circumstances, like you brought up the beaver in Scotland, where it was able to do some good. As a surgical tool, it could do some good, but it's being proposed as something that will solve a lot of problems, and it just doesn't have the weight behind it.
And going to your animals that have recently become extinct from 200 years ago, in that 200 years, the Earth has completely changed. Bacteria has completely changed. Using antibiotic resistance as an example, look at that now. In the past, say, 20 years, bacteria have nearly become resistant to all forms of antibiotics. There's a species of bacteria that's resistant to a last line of antibiotics, and that's in a very short time that it has become resistant to that. So in that 200 years, how much has the Earth actually changed? So you're going to bring back a species that's not going to cope with those changes.
Okay, we've got another audience question, so we'll just go over here.
Another question from the opposition. Do you not believe that this de-extinction effort sort of sheds light on how people are, I don't know, lazy and want to shed their own responsibility? Yeah, we screwed up the planet. We made the planet almost inhabitable to ourselves. So let's just bring some species back to life and try to, do you fix it?
I think it sort of shows the opposite, because it shows that people are willing to try and make up for mistakes that humanity in general has made in the past, like the extinction of these species, and that we're willing to not only to try and stop the mistakes we're making now, but to correct the mistakes we've made in the past.
Do I have a right to respond?
You can respond all you want.
Okay. For example, like you're talking about bringing species back to life, but I would personally think that should be sort of like a last resort type of thing. Like firstly, I mean, nobody's going to slow down cutting forests in China or Brazil. So I think bringing species back to life while that is happening, I think that would be just a waste of time, resources, and just lead to a dead end. And, yeah, that's my point.
Right. A response from here, and then we'll take a point from here, and then we'll wrap it up.
I would like to thank David for winning us the argument in the debate, because you just said that as a surgical tool, this de-extinction could work, and that is basically all we are proposing. We're not saying that de-extinction or de-extinct a bunch of animals or plants from the past will cure or be the ultimate solution for all conversational efforts. We're just saying that we should definitely do some research. The topic of the debate is the research, or is the process of de-extinction a beneficial and ethical thing to do? And we just say that yes, we should put resources into this research to not necessarily put some animals that have been extinct into ecosystems and hope they will fix stuff, but through this process of the research we can gain knowledge about genetics and a lot of things. I am not an expert, but I know enough about science that not doing science into something or research into something you could do and that is feasible has never helped anyone. And we are just proposing that we should try to and not dismiss this aspect of the genetical science just because we don't think, or just because some people think it's not valuable enough and doesn't bring anything. Because I think even the process of researching it will provide valuable results, even if it doesn't bring back the mammoth.
Just before we go here, we've got another audience question.
Thank you very much for your arguments. It's been really interesting. I have a question for the foresight. With the bringing back of an extinct species, there will be quite a high toll of animal models that will be required in order to do that. So do you feel that it is ethical to have this such high taxation, like this high volume of current animal models used in order to bring back the new species? Like, is it worth that payoff? Like, for example, like Dolly the sheep as an example, it's cloning, it's not de-extinction, but hundreds and hundreds of sheep died to have one viable clone. Like, is that payoff worthwhile?
I think you have to compare it to how we already use animals, to like how we breed and sort of exploit animals already in like commercial meat or milk production. And I don't think there's a huge difference between using animals as a resource for food or for labour, and between using animals as a resource for advancement of, for the advancement of science and technology. So while I absolutely accept there's a moral and ethical question there, I think it's more about how humanity uses animals overall as opposed to this specific point.
Any last minute questions from the audience before I go to closing statements?
Again, for the foresight, humans have been encroaching on ecosystems all over the globe. And although, because of conservation efforts and starting to realize that, hey, maybe we're kind of screwing up the planet and everything else on it, that has slowed down, not stopped. Humans will continue to encroach on those ecosystems. With those ecosystems already strained and with species already dying off and many more being endangered, as has the opposition already said, how can you possibly justify introducing even more species? Wouldn't that put a strain on the resources of those remaining ecosystems?
Well, we wouldn't. That's the point. We wouldn't do it where it places a strain. We wouldn't reintroduce a species where we think it was going to do harm. It's a surgical tool, as Dustin was saying. It's not it's not like a hammer. We would only do it where we had as much of a certainty as we could have that it was going to be possible.
One last audience question.
This is directed, I think, more at the foresight that I imagine that is something useful to add. In discussing the de-extinction of a species, a lot of the noise seems instead to be about the de-extinction of some representatives of that species, not a population. Shorn of learned behaviours, social interactions within that population, gut flora was introduced, or the pathogens that were endemic within that population. Were we to bring back, let's say, a number of passenger pigeons, would that represent the de-extinction of a species, or would we merely have a collection of passenger pigeon-like creatures, not necessarily a population thereof? If the latter, is that de-extinction, or have we just created something new and different?
Well, I think in many ways it would be the latter, because you're trying to create a sort of hybrid creature that has as many properties of the extinct passenger pigeon as you could. It might not be possible to create a perfect passenger pigeon as if you just stepped out of a time machine. But I think the benefits of doing it are that it might fill gaps in an ecosystem that currently alive species and currently alive creatures don't. And I think on a certain level you would be creating a new creature, but I don't think that's a reason not to do it. I think it would be worth doing if it would increase overall biodiversity and sort of aid conservation.
Increasing biodiversity by creating something which did not previously exist?
By creating something that was as close as possible to something that previously existed.
Are there any more last-minute closing statements that your side would like to make?
Yeah, I'll make one. To be honest, I actually kind of agree with the last point you raised there. The environment no longer exists for a lot of these animals, even the recent ones. The animals themselves no longer exist, the social aspect, all the minor things. So in really what respect can we call it the same animal? So now what we're looking at here is a human-designed creature for human purposes that will most likely have to rely upon us for a very long time. So we've got to ask ourselves why we're doing this. And the proponents of it do say it's to bring back a species. I'd say we were not doing that. But on top of that, raising biodiversity seems like a good thing, but the problem is we're so bad at maintaining biodiversity with the current environment now. Can we really claim to have a decent enough understanding, or even the practicalities of it, because the politics of it will enter it. We have to cooperate with governments. We'll have to find locations for it. Can we really say we don't just have the scientific knowledge, but the social knowledge to bring this project together in a successful way? I do agree that as a tool, it could be used well. But in the world we live in, and for the purposes which is being pursued for, I don't think it is ethical or beneficial.
A brief rebuttal, sorry.
On you go.
A brief rebuttal to Dustin. Dave hasn't quite torpedoed our argument quite as much as you state. I wonder if you have two options, both of which would work, but one of which doesn't require the de-extinction of species, which is more ethical to use. I would argue that the examples that you gave in your opening statement were very good examples of European beavers and grey wolves. Those are animals that we understand relatively well, particularly in comparison to extinct creatures, because they're still extant. We still know the kinds of environments in which they live. We have living specimens we can study. We can observe their behavior. And so would we not put the use of perhaps inserting an extant species into an environment for these positive benefits over the de-extinction of a species for the insertion into an environment for these benefits? Even then, we'd have to be very careful. I mean, look what happens with rabbits and cane toads and grey squirrels. But in those cases, were we certain of the positive benefits, I would say still using an extant species for that purpose would still be more ethical than using a resurrected species in that case.
Brilliant. I just want to say that you guys are all fantastic and your arguments were brilliant. Really proud of you all. After that debate, can I just ask for the motion? This House believes that de-extinction is ethical and beneficial. Who is now for the motion? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And who is against it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And who abstains? 2. Okay. Is that 3? Okay. Alright, and on behalf of the Debating Society, I'd just like to really thank the Bioscience Society for doing a debate with us. It's been really great, and you guys have been really fantastic to work with, so thank you very much.
Just along the same lines, really want to thank the Debating Society. It's been fantastic to work with. Thanks to all our panellists. Thanks to everyone for coming. I'd like to extend an invitation to everyone to head over to the Student Centre where we've got cold wine and hot pizza. I'm going to discuss the motions further and hope to see you over there. Thank you very much.
Good job.
Hopefully it's nothing like that. We don't meet
Well, then, these waited ones